Coming to the second important property of positive integers, that is the fundamental theorem of arithmetic. Okay, the fundamental theorem of arithmetic states that every composite number can be expressed, that is factorized, as a product of primes, and this factorization is unique, a part of the order in which the prime factor occurs. Okay, in simple, what it states, each and every composite number can be factorized as a product of prime numbers. Okay, see, do you know what is a composite number? A number is said to be a composite number if it has other factors than one and itself. Okay, now let us take an example. 32,760. I can write this number as a product of primes like 2 into 2 into 2 into 3 into 3 into 5 into 7 into 13. That is, I can express this number 32,760 in terms of product of primes as 2 power 3 into 3 power 2 into 5 into 7 into 13. Okay, this process is also called as prime factorization. Okay, let us see some more examples to understand the concept better. Okay, example 6. Find the LCM and HCF of 6 and 20 by the prime factorization method. Okay, now first we have to find the prime factorization for 6 and 20. We know that the prime factors for 6 are 2 into 3 and the prime factors for 20 are 2 power 2 into 5 power 1. Okay, now if you want to find the HCF and LCM for these two numbers by using prime factorization method, there is a note that to find HCF, the HCF is equal to the product of smallest power of each common prime factor in the number. That is, if you want to find HCF, first we have to see what are the common prime factors in these two numbers. Okay, now from comparing 6 and 20, we have 2 is common prime factor in both the numbers. So HCF always deals with the smallest power of common prime factor. So here for 6 it is 2 power 1 and for 20 it is 2 power 2. Hence the HCF deals with the smaller power. The HCF of the two numbers 6 and 20 is 2. Okay, now if you want to find LCM, LCM is equal to the product of greatest powers of the prime factors present in the two numbers. That is, if you want to find LCM, what we have to do? We want to see what are the prime factors that are available in the given numbers. We can clearly find that for 6 it is 2 and 3 and for 20 it is 2 and 5. So 2, 3 and 5, there are 3 prime factors available in the given two numbers. Now LCM always deals with the product of greatest powers. So for 2, the greatest power when compared with two numbers is 2 power 2, and for 3 the greatest power is 3 power 1, and for 5 the greatest power is 5 power 1. So LCM of the given two numbers 6, 20, which is equal to the product of 2 power 2 into 3 power 1 into 5 power 1, which is equal to 60. Okay, let us see another example. Note, for any two positive integers a and b, the product of the two numbers a into b, which is equal to the product of their HCF and LCM. Okay, okay, it is possible only in the case of two numbers given. Okay, let us see another example. Example 7. Find the HCF of 96 and 404 by the prime factorization method. Hence find the LCM. Okay, so here first we have to find the prime factorization for 96 and 404. We know that the prime factors for 96 are 2 power 5 into 3 and the prime factors for 404 are 2 power 2 into 101. Okay, now HCF. What we know HCF, if you want to find HCF, first we have to do what are the common prime factors in both given numbers. We can clearly see that 2 is the only common prime factor available in the two numbers. And since HCF always deals with the smallest power, here 2 power 2 is considered as the LCM for the given two numbers 96, 404. Okay. Now, here if you want to find LCM, what you have to do in general, we want to see what are the prime factors that are involved for these two numbers. So the prime factor involved are 2, 3 and 101, and LCM is always deals with the greatest power of each prime factor involved. So LCM is equal to 2 power 5 into 3 into 101. But here they are asking we have to find LCM with the help of the note given, that is the product of the two numbers, which is equal to the product of their LCM and HCF. We already know that the HCF of these two numbers is 4 and the product of these two numbers is 96 into 404. Hence LCM of two numbers 96, 404 is equal to product of two numbers 96 into 404 divided by HCF of 96, 404. Okay, this implies 96 into 404 divided by 4, which is equal to 9696. Whatever the method you choose, the answer becomes same. Okay. Example 8. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. Okay. Now, first we have to find the prime factors for 6, 72 and 120. We know that the prime factors for 6 are 2 into 3 and the prime factors for 72 are 2 power 3 into 3 power 2 and the prime factors for 120 are 2 power 3 into 3 into 5. If you want to find HCF and LCM, first for HCF, we know that we want to see what are the prime factors that are common among the three numbers. Here we can clearly see that 2 and 3 are the prime factors that are common in all the three numbers. So since HCF deals with the product of smaller powers of common prime numbers, then the HCF of 6, 72, 120, which is equal to 2 power 1 into 3 power 1, that is 2 into 3 is equal to 6. Okay. Now, if you find LCM for the given number 6, 72 and 120, what we have to do? We have to see what are the prime factors that are involved in all the total three numbers. See, we can clearly see that 2, 3 and 5 are the three prime factors involved among 6, 72 and 120 numbers. So now what we have to do? LCM always deals with the product of greater power of the prime factors available in all the three numbers. Since the LCM of 6, 7, 120 is equal to 2 power 3 into 3 power 2 into 5, that is equal to 360. Okay. Here in the previous sums we note that if the product of two numbers which is equal to the product of their LCM and the product of their HCF, but here in the case of three numbers, the product of three numbers is not equal to their product of LCM and HCF. It is the note which we keep in mind in order to solve the further problems, right?